Serhiy is Director of Architecture at SoftServe. He has 15 years of professional experience in designing and developing enterprise solutions. He's leading an architecture team of more than 30 architects who have expertise in big data analytics, cloud computing, and mobility. And Olha is a data architect at SoftServe. She has more than 7 years experience in BI, data warehouse, big data projects. And currently, she's leading the BI Center of Excellence at SoftServe, designing data warehousing and analytics solutions. Their talk, as you can see, is Big Data Analytics, Reference Architectures, and Case Studies. So I'll turn the show over to you.
Thank you. Thank you, Rick. It's our pleasure to share some of our experience to so architecturally savvy audience. So today we will talk about a trade-off between modern and between traditional, a trade-off between relational and non-relational reference architectures. So these are just a simplified biological view, and at some point in this presentation we will change it to more sophisticated abstractions. So we will start with big data challenges and how these challenges drive our selection of big data reference architectures. So basically, we distinguish three architectures: relational, non-relational, and hybrid architecture, which is a mix of relational and non-relational. We will illustrate how to make a trade-off between architectures with real-life case studies, and at the end of presentation, share just a couple of tips how to design big data analytics solutions to avoid any unpleasant pitfalls during development process. So, Ola?
Okay, thank you, Serhiy. Do you hear me well? Big data is being generated by everything and is everywhere. Every digital process, mobile device, sensor, social media produce it. So there are a lot of various type of data which were not so intensively used previously. Big data has become too complex and too dynamic to be able to be processed, stored, and managed in a traditional way by traditional tools. So to extract a meaningful value from it, it requires new processing power, it requires new architectural approaches and new skills. There are four main challenges with big data. They are velocity, variety, volume, and complexity. And actually, they form the main drivers for your solution architecture. So you can see from the slides that depending on the nature of your data source, these four drivers can be represented differently. And this actually defines the way how you should work with them and defines how complex your solution is going to be. So, for example, the more unstructured your data is, the more complex is to work with it and to process it and to make analytics on top of it. So, big data introduces new ways for data analytics. In comparison to traditional analytics, big data analytics shifted the focus from the questions like what happened and why did it happen to exploring new insights, to looking for new hypotheses, to asking new questions like what will happen, are there any risks, are there any anomalies, what should I do about this? With big data, data scientists and others are able to analyze really huge volumes of data, to work with raw data and more varied types of data, make different combinations of it. And it was not possible with conventional analytics. And as a result, by using high performance data mining, predictive analytics, machine learning, some optimizations techniques, you can discover hidden patterns, you can discover unknown correlations, and as a result make a better decision, more data-driven decision, and can drive the innovations.
Oops. So, yeah. So here are the big data analytics use cases or business patterns, if you will. For simplicity, we just pick 3 of them. So let's start with data discovery. Here we go. So the data discovery is based on the motto, if you will. Let's collect first information and then find something useful there. So the major players for such systems are data scientists and data analysts. And the usage of such business pattern is across all industries. So starting from retail and ending with healthcare. So just an example is finding correlation between customer behavior and sold goods in retail, or patient DNA sequencing and effectiveness of drugs. So these are just a few samples of data discovery. The real-time intelligence often is based on a foundation that was built by a data scientist or data analyst in form of predictive analytics model. And the challenge here is to make a decision quickly and make this decision in a matter of milliseconds or in a matter of seconds. So the challenge here is low latency, and the challenge here is reliability, because our users for such systems are consumers and intelligent agents. The short business pattern is business reporting, and this is more kind of traditional thing, but at the same time it is based on big data, on refined data from multiple sources. And the challenges here are data quality and self-service for business users, such as ad hoc reporting, for example. So let's have a look at the business, how business converts to architecture drivers. And we see that there are the architecture drivers lead to different reference architectures. From multiple projects that we designed, we see that there are 3 major groups of architectures. Extended relational, which is primarily based on RDBMS and SQL concept. Non-relational, which is based on NoSQL, which is based on Hadoop and based on search engines. And hybrid, which is a mix between these technologies and probably some other technologies as well. So here is a let's say, traditional reference architecture for data analytics system. The data starts from left side and goes to presentation layer. So these are just 5 layers, and the 3 layers in the middle represents this data analytics solution. So what are the challenges here with big data? That some of these components, such as data warehouse, data mart, and a lab cube, becomes bottleneck because of this amount of data. So at the same time, the vendors of relational techniques also improving their technologies. So such as MPP approach, which stands for massive parallel processing, allows us to shard and to replicate data to multiple servers. Another technique from extended relational is column-oriented architecture, which help us to perform queries much faster because the data is stored in forms of columns instead of in a row-oriented fashion. And in-memory analytics tools basically replace lab cubes because of their flexibility. So just a few vendors from MPP and column-oriented architecture, such as HP Vertica, such as Teradata, Microsoft Parallel Data Warehouse, Amazon Redshift, and in-memory analytics such as Tableau or ClickView. And at the same time, this architecture doesn't solve all big data problems, because there are issues with unstructured data. So what is good? So what is bad for one is good for another, and that's why there is a great niche for non-relational architectures, which are primarily based on NoSQL databases. And by the way, yesterday there was a great training by Jan and John. They shown the concepts of NoSQL databases in very much details. Also, distributed file systems is a new component here. And Jeremy, I believe, will talk more about this in regards to MapReduce, which is basic analytics techniques to process big data. And also search engines such as Elasticsearch, Splunk, Solr, new technologies that help to work with unstructured and semi-structured data. So here's a trade-off between extended relational and non-relational architecture. And let's have a look at the strengths of a non-relational architecture. Large data volume. Hadoop, for example, can effectively process tens of petabytes, and comparing to even MPP, even extended traditional approach, this is like a huge advantage. Self-service, or let me go first with non-relational advantages. Unstructured data processing is non-relational technologies forte. And high data quality and high data model extensibility as well, because they are schema-less, and you can change your data model on the fly in real time. And low cost because there is either zero cost associated with these technologies, or low cost because of open source nature of these technologies. And what are process of extended relational? Self-service or ad hoc reporting, which is ability to create custom reports based on different dimensions. High data quality and consistency because of their relational nature. And extensive security because RDBMS concept and technologies are already 30 years in place in enterprise, so that's why they are quite mature. And of course, skills availability, because extended relational based on traditional concepts on RDBMS and SQL, and that's why IT labor market is much more better when comparing to NoSQL or Hadoop specialists. So again, just another view on this trade-off, and choose what you think is the most appropriate for your purposes. Okay, so let's do a quick exercise with every business patterns that we see here. Let's start with data discovery and see how data discovery architecture can be built with non-relational components. So we have three different sources: structured, semi-structured, and unstructured. And all this data is integrated and stored in distributed file system. MapReduce is used to process this data, to make a queries, and if we map this to a technology stack, we will see that it fits to Hadoop, actually, Hadoop ecosystem. Messaging could be done using Flume technology, Scoop for ETLing structured data, and HDFS as a distributed file system. Hive is a query and a query engine which runs MapReduce without need to write MapReduce manually. So this is a great platform for data scientists and data analysts to find useful patterns and correlations in data from multiple sources. A business reporting system. So here is a hybrid architecture, a sample of hybrid architecture. We can see components from non-relational world and components from relational world. So in this architecture, big data is refined and stored in a relational data warehouse so that the data warehouse shows all the refined data through traditional BI tool, which could be like a SQL tool. If you map it to technologies, we can see that, again, Hadoop can be used as a non-relational storage, and Talent can be used for ETLing structured data, and Vertica, for example, MPP technology can be used as a data warehouse, which stores all the refined data. So in this scheme, Hadoop takes place or plays role of ETL on steroids, if you will. And real-time intelligence case, here is a view of Lambda architecture. And by the way, how many of you are familiar with the term Lambda architecture? Good. So some people already know about it. So the Lambda architecture introduced by Nathan Morse, and Nathan is a creator of Twitter Storm. And this is quite elegant solution how to process real-time data and at the same time have access to historical data as well. So you can see here the speed layer, which can be based on a complex event processing such as Twitter Storm, and batch layer, which can be used again on Hadoop with batch views, which could be NoSQL databases. So the historical information is stored here, and the process can be hourly or even on a daily basis. But the speed layer translates all this data to real-time views in a matter of milliseconds or seconds. So in this case, you have access to all your information regardless when this information came into the system. So let's start with a real-life case study. Usage and billing analysis, it is based on a cloud platform which is used for creating mobile applications. And the architectural drivers in this case were extensibility, data quality, and self-service. So the trade-off shows that there are two wins, at least in data quality and self-service for extended relational, and at the same time there is cons in extensibility, where non-relational has a great advantage in this. So it means that we need to do something with this con, right? With this cons. So taking extensibility pattern in a relational world, which is pre-allocated fields, where we could overcome this issue. We could work around it. And by the way, column-oriented architecture allows you to add many columns comparing to traditional RDBMS without significant performance degradation. So here is the solution architecture, just a high-level view on it, and technology stack. So it was based on Amazon Redshift and Amazon SQS S3, and Python was used to ETLing these messages.
Okay. So the second case study is related to retail, and so this is a big e-commerce platform, and the idea was to build an in-house analytical platform to measure the ROI and also to analyze the performance of each feature, each product that was delivered by this platform, how users are using it, how users are interacting with the platform, analyze, to do some clickstream analysis, and also to perform some A/B testing. So this is not a Google Analytics-like platform because it is more oriented on collecting more granular data, more specific data, in order not only to improve the marketing campaigns, but also to analyze the user behavior patterns and to provide some recommendations to user in order to increase the sales. Also, there is a big data scientist team that is working with the data collected with this platform, in addition to the other sources that they are working with. So here, volume, throughput, extensibility, and self-service via data discovery were the main, the most significant architectural drivers. So currently, solution has around 45 terabytes of data, and it is expected it will have more than 100 terabytes of data in the nearest future. Also, since the solution is used by millions of users, the throughput was really very critical. So currently it has more than 20K of events supported per second. And since the platform is growing, so new features, new products are being added, and new custom tags appear. So the extensibility was very critical for us, and the solution had to be extensible, had to have extensible data model. Self-service via ad hoc reporting was not very critical since the platform was used mostly for internal needs, and it was enough to have some candidate reports, some predefined reports, but data discovery for the data scientist team was critical, and there was a big stress on it. So after analyzing thoroughly all the architectural drivers, after doing a trade-off, a non-relational architecture was selected. First of all, because of its scalability and extensibility via NoSQL stores. Also, NoSQL stores are not an effective way for creating a data mart for ad hoc reporting, but column family DBs such as HBase or Cassandra allows to create materialized views, to create some aggregation views in order to provide some custom reporting. So in order to implement a candidate reporting in this solution, a materialized view pattern was used. So here you can see the high-level architecture of the solution. So all raw data is stored on the HDFS Hadoop. The aggregated data optimized for the reporting, so aggregated views stored on HBase cluster. So there are some custom scripts with which transfer the data from intermediate storage S3 to HDFS. Also, there are a set of scheduled MapReduce jobs that aggregate this data, create these aggregated views, and store them on a dish-based cluster. So the whole solution is hosted on the Amazon, and this was actually the architecture constraint. And as a result, the UI layer is custom.
Mm-hmm. So we don't have much time, I believe, and yeah, just tips for designing big data solutions. So here they are, and I would like just to mention that you need to prototype, so actually, and re-evaluate your architecture, because these technologies are quite new, and there are a lot of bugs, a lot of defects or unexpected features. All right.
Okay, thank you. So we have about 5 minutes for questions. Don't be shy. Yes.
Did you find the Amazon architecture reference helpful in your case?
Amazon architecture reference?
Yes.
Reference architecture, you mean?
Amazon is several suggesting how to use the...
Yeah, exactly. So we did a trade-off between Amazon RDS and Amazon Redshift. And Redshift at that time was in beta version. And Amazon reference architecture helped us to build the application part of this solution. But at the same time, we had to make our own trade-off between using RDS or between using Redshift.
Quick question. You have some hybrid architectures up there that talk about, basically using relational, non-relational types of constructs. So can you tell me more about? You had ODS up there for a second. Have you gone through any projects or engagements where you saw the latency requirements were so low that you had to have something that kind of mixed and matched so that it could fulfill that user experience?
So the Lambda architecture actually is a good case when building such hybrid. And at the same time, you can process in real time. You mean a low latency. It was a driver, right? So low latency is exactly the case when you need to have a look at complex event processing. So if you have restriction to seconds or milliseconds, so this is I would say, the only choice there. And if we are talking about new real time, so for these cases, actually both architectures could work. We found that micro-batching in relational solutions also allows to achieve minutes, so 2 minutes, for example. And the same with NoSQL. If you have the update within a few minutes, you can achieve refresh of your materialized views and be able to read the new information from it. And as well with search engine. So search engine is like a bit another animal in this like a zoo. But anyway, it allows you as well to do some kind of operational intelligence, near real-time operational intelligence.
One final question, a brief one. I'll ask a question, then I'll take chair's privilege. So you talked primarily about performance, and I know to a lesser extent we often worry about availability in these kinds of reference architectures. Do you have any experience with security or modifiability concerns? Can you compare the architectures with respect to those?
Yeah. So security is a big question for NoSQL databases. And there is a big diversity in implementing security in different NoSQL databases. And right now, this area is evolving. So if we have a strong compliance, strong regulation compliance, we need to choose very carefully in this regard. So for example, HIPAA, which also has some technical safeguards for data in REST.